Good morning, everyone.
Very good morning.
All right. Welcome to another code long session. Today, we'll be working on a problem statement, which comes from an open source data set, which is showing us different water levels and rainfall levels from the city of Chennai. And we would look at different analysis to investigate if there are any water problems, if we can use it to forecast anything, or to maybe better prepare ourselves. So what I thought today we do is, instead of using Jupyter notebooks locally on your computer, I thought let's try using open source, another platform in which a lot of data scientists get they participate in different competitions, and they work on a lot of different data sets and can publish their code for the community to work to comment on, and also maybe mesh it with any other data set that's also available. So I think most of you would have heard of Kaggle. For those who haven't heard, Kaggle provides a lot of open data sets which you can use and start playing with, create notebooks and share it with others, and also have discussions around different types of notebooks and different types of data, or even analysis. And so you can create your notebooks in Python or R. Kaggle started off as a place where big corporations or small corporations had some data, but they didn't know how to get some insights from those data. And so they started off as competitions where people participated, and if their code won or performed better on a test data set that they were holding up without showing it to the participants, if that performed well, they would win that prize money. So you can still see there are still a lot of competitions that are active. So if you want to try your hands on these different data sets, you can pretty much participate in any of these. And then if your code is good enough, you can win this much prizes as well. So I thought, okay, how do you want to get started into this? This is another good platform to get introduced to yourself. So first thing that you would need is to be able to use this platform is sign in. So I've already created an account and I've already signed in, but if you haven't, then it's very easy to sign up. Just go to register and use your existing Google account if you have, and then just sign in based on that. So since I've already created an account, I'll go ahead and just sign in myself with that account. Now, once you have an account, what this allows you to do is save your work, share your work, and comment on other people's work. So let's begin by first creating a new notebook or searching different data sets that are already available. So you can either start from a data that is already available, or you can start from a problem and then see if there are data sets available within Kaggle and start using those. Or you can bring your own data set as well, and then you can register it. If you think this is private, it should not be shared with other people, then you can just keep it to yourself. Or if you think this is something that anybody can use it, then you can publish it here as well. And so depending upon the type of data set you would have, so for example, today we're working on the Chennai one. So just look for Chennai water. You can see Chennai water management. So this data set will tell you how many files it has. So it can have multiple files. So imagine you're working on an image recognition, then you would have a lot of labeled images. For us, we have tabular or structured data. So we've got two different CSV files associated in this data set. And every data set comes with some sort of license. So can you use it? Can you share it? How can you use if it is some sort of a license? So if it is private, you may don't want to share it with other people, but you can of course upload it, and Kaggle may know what you've uploaded. If you don't want to introduce anything, you can just upload it during the session. We can see that how we can do that. But for us, we have a data set that we want to work with today. So you can just search for this data set, open it up, create a new notebook directly from this URL. When you do that, you get to a point where this data set is already loaded for you in your environment. All you need to do is start working on it. So this is one approach where you have a data set and you want to explore it further, or you want to do some analysis on it. Maybe there's another approach in which, for us, for example, we already have some questions that we want to do. So we already have a questions notebook, which is asking us to do certain analysis. So I have a problem statement. I'm now trying to find the data for it possibly. This is a second scenario. So if you have this type of a scenario, what you could do is you can download this notebook onto your local computer. Okay. Yep, so this is raw. And so if I right click on that, save link as, then I can save this notebook on my local computer. So I have the notebook saved locally. Then what I could do is I could simply say import the notebook. So upload notebook. And when I do that, I can I'll get all my cells like this here. So I get my questions available here. So this is how we can start. We can either go to the notebook, we can go to the data set and create a notebook from there, or we can just go to the notebook section of Kaggle and say new notebook and upload our own content. So with this, I already have the questions that I need to work on. All I need is the data set that I need to work. So again, you can add the data set or upload the data set. So if you have your own data set, you can upload, or if you want to use one of the Kaggle ones, you can just search for it. So if I just go Chennai, there it is. So I can just simply add it here. So this data set is available in my session now. Now you might ask, Manish, how would I use this data set? So by default, Kaggle uploads all your data sets within the folder called Kaggle input. So if I just do an ls in that particular folder, what this is going to do is going to show me the folder structure under this input directory. So I can see there's a folder called Chennai water management. But if I just want to see any file under that folder or any other folder under input, I can just simply use wild characters like this. So what these wild characters are doing, it is recursively looking for any file available in the subtree of Kaggle input. So I've got two files that are available, and I can use that. So if you add any other files by uploading or by choosing, then those are also available under Kaggle input, but it would be available under a different subfolder. And so depending upon how big the data set is, how many files the data set has, this output would show up differently. Now, if you don't want to run any Linux code, so this is a Linux command ls, but if you want to directly look up the files that are available within Python, then you can use a library called glob. You can try import glob, and you can say glob.glob and pass the same sort of argument to it. You can see it would return a list with all the file names. So pretty much ls and this wildcard is running glob in the background. And so I can run it as a command on the Linux side, or I can run it from the Python side. And then I can use this list to import my data sets. So I could just simply say data sets or CSV list. So I can then now use this variable CSV list to read my files, to read levels, rainfall, and any other file that I need in my session. So this is how you could kind of parameterize your code as well. So you don't have to hard code the values in it. Okay, so this is something I think if you are trying on your end, you should be able to first get your notebook uploaded, attach the data set, and you should have at least this output in your site. So let me know if you are not able to get to this point, or if you've successfully loaded the data set in the chat, and then we can proceed further. And again, the commands that we use in this, it's essentially a Jupyter Notebook environment. So all the commands that you are familiar with, up arrow, down arrow, edit mode, command mode, markdown cells, Y and A to add cell, D to delete. All these keyboard shortcuts, they still work because this is still a Jupyter environment. So if you just want to use your local Jupyter environment for today's session, that's fine too. Manjunath is asking, how can I load my own set of notebook? So you could go to File and click on Upload Notebook. And then look for your IPYNB file. If you've already downloaded from the GitHub repository, if you haven't downloaded from GitHub repository, you first have to download it. You can open this URL and then right click on the raw and say save as. So if you save as, it saves as a IPYNB, and then remember the path where you download it, use that to upload here. Now this is just to get all the questions that we have, so I don't have to retype anything in this session. I've got the same environment that I would have on my local. I have it in my Kaggle as well. So when I say environment, I mean all the questions. Okay. So Harsh is asking, how is Colab different from Kaggle? In terms of execution, it is not different. However, Colab does not have any data sets feature as such. So if I want to do any analysis, I need to attach my data set to it. However, in terms of the compute power, you do get nice compute here as well. And I think you also can put a GPU and TPU. So in the background, it is same. And since Google acquired Kaggle, they have kind of merged the backend. So you'd find all the features that Colab provides in the backend. Kaggle also provides it. The difference with Kaggle and Colab is it is more social. So I can just share my notebook with you, and then you can use my notebook or you can comment on it. In fact, with a lot of competitions, people kind of share their analysis with each other and form different teams. And so this is what Colab doesn't provide. It is not meant for competition. It is not meant for doing data science, but it is more around saving your notebooks in Google Drive and then using it in the Colab environment. So here my notebooks are not saved in Google Drive, but they are saved, everything is saved in Kaggle environment. Okay, so I'll just rename this. I'll say code along. All right. Okay, I hope a few of you have got the data set loaded in the Kaggle environment, and the notebook also is available for you to work on. If for some reason you don't have the notebook, that's fine too, because the code is what we'd be filling it up with. The questions, you can fill it up later as well. You can get it later as well. Okay, so today we would not need so many libraries. We would just need NumPy, Pandas, Matplotlib, and Plotly Express. So I've loaded my file. Then I'm going to read my data set. And so if you recall from above, I have my name of the file already stored in the list. So I can simply use that list. I can simply say pd.read CSV. And then I can create a data frame out of it. I can say head, and I've got the data loaded. And so this data is the reservoirs levels. We already also have another data, which is reservoir rainfall. So what is this data set that we have today? You can see it's got some date timestamp, and it has 4 different reservoirs that are in Chennai. And so these reservoirs store the rainfall water and are used to supply the water to the community in Chennai. And so it's very important to keep track of how much of the water is available, so that if you want to ration it, you can create certain policies as a municipality or the city officials. And so this data set is captured at a daily level. You can see every day of the month of that particular year, what is the availability, what is the water is available in that particular reservoir. It's captured in million cubic feet. And so the data comes from different years. And so what we need to do is first understand the data itself and see if the data types of each of these columns are properly set. And so if I check for the data types, you can see the date is not recognized as a date, it is recognized as a string. So first thing you would want to do is want to convert it into a date data type. And so to convert this into a date data type, what we can do is we can use ed.toDateTime method. And then in here, we can pass so many different arguments. We can first pass that series. So, and then we can pass the format and some other variables like day first or year first. So let's pass that. In India, we usually follow DDMMYYY. So that is the format we follow. You can provide that information in here. You can say df.date. That's the series I want to convert. and the format is dd mm and then YYY. So if you pass that information and then run it, it is going to return a column with the date type. It correctly recognizes this is year, month, and the day. And then you can use this now as your data type. So we can overwrite as your column, date column. So we can overwrite that. We can say df date like that. And so if I rerun the D types, now I would see this is correctly identified as date. Now you might ask, Manish, why do we care for us to be able to recognize this date as the date type? The reason is if you have the dates, if you have your columns correctly typed, then you can use certain features from pandas. So if you want to extract the month, you don't have to go to different string operations. You can directly use date.dt and the month. And if you want to add or subtract two dates to get the duration, you can again add or subtract two dates. And pandas would know how to subtract it and how to get it into days or months or years. And so date manipulation becomes really easy. Even it helps in plotting. So because Plotly understands different data types, and depending upon that data type, it can create the scales for you on the fly. And so if you correctly set your data types when you are reading or when you're creating data frames, then your plots also become the axis, the scales of your plots also are correctly assigned, and you can manipulate those. So it's a useful thing to do before you start doing your analysis. One last thing I would wanted to talk about here is you can, if you know what dates you are working on, you can simply also say here, so you can say parse dates, and you can provide the columns that are of date. So if you have multiple columns, you can just simply say all those columns, and pandas is going to try to parse these and create a date column for those right at the reading side. So when I'm loading my data, I can directly say it here. And then I can also say, because I know my dates are having day first, I can say day first true. The default value of day first is false. So what day first is telling whether the day comes first in the string. And if it is so, then it can correctly parse it. And if it is false, then the month is appearing first or the year is appearing first. So for formats like MMDDYY, which is the American style, this would be false. And that's why the default value for this is false. And so if I just do this and then check for data types, you'll see the data types are correctly set, and I did not have to transform it after reading. So during the time of reading, I can simply say parse these columns as dates, and the format is like this. I don't have to specify it here. Okay. All right, so we've got this. Now a quick check would be, another check would be to look for any null values. This data set does not have any null values, so it's a good sign. We don't have to do any data cleaning today. All right. So data is loaded at each row is 1 day. So if I ask you a question, do you think this is a tidy data frame? What do you think? Is this a tidy data frame? So if you recall from previous sessions, the tidy data frame was supposed to be like every column should represent one variable. Now, if we assume reservoir as a variable, I've got 4 different reservoirs, so I have 4 different columns. This is like a wide data set. In a tidy data set, each column should have one variable. So this doesn't look like a tidy one. So yes, to convert it into tidy, what we will need to do is use melt. So yes, let's use the melt to get the correct output. So if I go df.melt, I need to pass a few variables which I do not want to change, which I consider as ID. So in this case, I consider my date as ID. And if I do not specify anything else, see what happens. It automatically converts it into a long data frame. So now one column has the name, the title, the heading as variable. I can replace that with a more descriptive name for our case. Let's say reservoir, and the value, again, I can say as water level. So essentially what I'm just doing here is assigning the correct labels or headings to these columns that are created. So it basically tilted or melted the wide form into the long form. And so now each row is one observation, each column is one variable, and each cell has only one value. So this looks much more tidy. And so if you have this data frame, what you could then do is you can use px dot bar or line. So let's create a line graph. And then we can specify many things. We can first specify our x-axis to be my date, and my y-axis to be my water level. If I run that, I'll get nice graph, but it's all mixed up. Okay, to avoid this mixing up of information, we could use the third information, which is the color. And in here, we can use the reservoir as our color. And when I add the color, then it becomes much more clearer, and I can see all the different traces. And I can double click or single click to hide or unhide, and I can quickly compare the two. I can see Cholavaram has the lowest amount of capacity or the availability. Possibly this is the size is smaller, or it just has low rainfall in that region. And the Red Hills and the Chimbaram, Bakkam, and Pundi have almost the same amount of rainfall or the capacity. But again, this is not very clear to analyze. We can get some insights, but if I want to draw my attention to maybe all 4 at one time, this is not a good way to show them. So another option that we could use is we can add facet. And so if I say facet equal to 2, made some mistake. Probably it's not called facet column. It's called sorry. I need to provide the name of the column. So I'd say reservoir. And then if I use the reservoir, then it creates different charts instead of putting everything in one chart. And then if I put facet column wrap, then it wraps after 2 cells. So it can have 2 after every, so in one row you'd have only 2 columns. So that is what you're doing here. So since we have 4 charts, it is 2 by 2, but if we would have had 6 charts, then it would be 2 by 3. So 2 columns and 3 rows. Now you might ask, Manish, how would I know all these different arguments? So for that, what we could do is we could visit the Plotly's website and look for the documentation. So if I say tx.line documentation, it brings up this documentation and I can read different parameters. You can see you can have facet column, you can have facet column wrapping, and also you can have spacing between the columns. And similarly, you can have rows as well. So you can not only divide it by row, but you can also divide it by columns and so on and so forth. So there are plenty of other arguments that we are not exploring today, but what we would explore next is the title. Let's add the title in this chart so that it's more readable. So I could say, and this is water availability. In Chennai's 4 major reservoirs. And because we added the date, you can see the scale is automatically 2004 to 2020. And if I hover over it, you can see the water level is changing and the month is also changing. If you wouldn't have changed this to a date type, this would have been treated as a string. And then this x-axis would be highly populated. So you would have every date treated as a single component, as a single plotting axis. So it would have lots of values in the x-axis. And because we converted it into date type, Plotly intelligently uses this as a date scale. So you can try running those fields and see what happens. So if I just remove that and rerun it, hopefully this time it is a string. And if I run this, you'll see the difference. Possibly you can see multiple values here. This is no longer treated as a date, it is treated as a string. And so that's why you should convert or load your dates as dates so that other libraries can take advantage of it. Okay, Harsh, you have a question on, sorry, what part? Prasad, would the date still be in order? No, date would not be in order if it is in a string form. If these were skipped, then the dates would not be considered as any form. It would just be in order of appearance. So it would sort, the Plotly library sorts your strings when it is using for plotting. However, other libraries may not sort it for you as well. So they may plot as and when the data appears in your data frame. And that is why if you convert this into a date type, not only your ordering is preserved, but you can see how intelligent the Plotly is. Instead of saying the date, it says April 2012. Okay, I think one last addition that I would want to do here is also create the scale of the time frame. So if I add the time frame in my title, it's more informative. Directly looking at the title, I would know from what time period I'm looking at. So if I have to add the time dimensions here, which is just the year from and to, there are plenty of ways, but the easiest way is to just use the format uh, functionality or the format way of specifying your strings in Python. So I'll just prepend this with F, and then I can use any variables in my code to get the values. So I can simply say df.date.dt.year.max or min. And if I use this, and if I use the max, you can see it will also populate the years from 2004 to 2020. Automatically is added. So if tomorrow my data changes, I can still have my plot showing the correct title. So it's not hard coded. This string is hard coded, but the rest of the string is dependent upon the data that I load. And so your code becomes much more portable across different time frames for the same data type, for the same data frame. So if it has the same type of columns, same names for those columns, but a different timestamp, maybe it was looking at 90s, 80s to 2000s, the same code will work on that as well, and it would accordingly update the title as well. So that's just a nice, quick way of adding more information into your title, making it more dynamic. All right, as always, once we plot something, we kind of add some sort of insights from here. So what insights do you see in this chart? You can see there's some dip around 2004, 2005, and then there's another dip in around 2015, which indicates there's some sort of maybe these years had some drought. Then there is another interesting pattern, which is like a cyclical, seasonal, up and down, more like a sine wave. It's very, very predictable that you can see how high it can go and how low it would go. And if you create some sort of a forecasting model, you can pretty much, with certain accuracy, provide what would be the max that you might expect and what year or month you might expect. So Harsh is saying Chimbaram Bakkam has same amount of water. I'm not sure what you mean by that. Seems if you mean by the height, yep, the peak is always around 3,000 million cubic feet. And so, yep, so there was the availability, there was no dip during the September time, which is usually seen in previous months or previous years. So these are good insights you can see, and it is same for all. And the September, November period of 2020 during the lockdown, the water consumption was considerably low, or people were not wasting a lot of water, something like that, or maybe we had a good rainfall. And so your forecasting models, if they are using historical data, would go all over the place. So yeah, Prasad is a good suggestion. It is because of the lockdown, the industrial use would have been low, and that's why the home usage would have been the same. So at the moment, we are not having that insight, but it's a good hypothesis. And if you can get more data, you can validate that hypothesis. So we can see there's a seasonal pattern of replenishment. replenishment and usage, and so this maybe coincides with maybe monsoon. So if we have monsoon, we may have our reservoirs being full to their brim, and after the monsoon, the dry seasons like winter and summer, people are using more. Seasonal pattern for increase and decrease of water availability, and some droughts in 2004, 2015 time periods. Interestingly, high availability during September, December 2020, possibly due to lockdown and low industrial use. Okay, these are some good insights that we've captured. So let's move ahead, let's go forward and try to see a bigger picture. The bigger picture would be the total availability of water and see if we have any, how can we create that insight? Can we create a total sort of variable? Now to create the total, wide data frames are usually easy to work with because you've got data that's spread across. What you could do is you can just sum them row wise. And if I sum them row wise, I get the total, daily total. And so I'll use the original data frame that we had and create a new column called total. So I'll use data df dot. If I want to make a row wise sum, I don't need the date column for that. So I could just simply say drop date. And if I drop the date, I can see I only have a data frame with all the 4 ones. And then I can just simply say sum. And if I say sum, I get the sum of water availability for Pundi. But this is a column sum. I don't need a column sum, I need a row sum. So I can just change the axis and this will provide me row sum. So Dhruv is suggesting, Manish, how can we comment there's a drought? It's just it is low rainfall or high water usage. So that's correct. You can say some low availability years. And if you just want to pinpoint on that, you can just zoom in that section and you can see, yep. Around here, water level touched 0 and stayed 0 for September and October period. Same is the case here. The water level was so low in June and July, it touched 0. And same is the case in so many different reservoirs. The water level is dropping or almost close to 0, which indicates that there was no availability of water in these major reservoirs. And if it is for many months, then that indicates very low rainfall or potentially drought, because you can see it's across different reservoirs. There could be another reason. There could be the data was not captured during that time. But if we assume the data is correct, we validated that point, then we can make that assumption, make that hypothesis saying, yeah, this is a drought period. Okay, coming back to the total that we were creating, you can always create a total just by adding multiple columns. I could say add Pundi with Chimbarambakam with Chola Varam and fourth one, which was Red Hills. So if I do that, I get the same data. Now with this, your code is again more portable. So I don't have to have 4 columns like this. I can have 6 columns. I can have 10 columns, or I can have only 2 columns, or maybe they have a different name. So this 2 code, they generate the same output, but the code which does not specify any column name and does the row sum is more portable, that you could apply it in different scenarios. And so this one is more readable, but this one is more usable, I would say. You have to make that trade-off. If you're doing some simple analysis, you don't want to repeat your analysis on different data sets, different time periods, you can pretty much run it like this, and that would be the same output. But think about it from a productionizing point of view as well. When you are trying to create this report on a scheduling basis, you may want to use this in this format. So if I just then assign this to a total, and then I go ahead, I get the output. So I have the daily total for each of these regions. I can simply create a plot like this. All I've done is I copied the code, and now I don't need this probably, because I already have my date, and instead of water level, I could just use total, and I don't need any of these. And that's the total. Okay, any questions? So this is the question that I wanted to ask. Shalini, what do you think? Why do we need to have a total, or what kind of insights can we get from total, which we cannot see from the individual ones? I think the one straightforward analysis that we can do is, at a high level, we could simply see how is Chennai receiving the rainfall, or probably how is Chennai's water situation. If you want to look at the city level, possibly. So if you have more than 4 reservoirs, if you have 10 reservoirs, you can simply run this code, and then this can give you a chart at the city level. But for specifically like this, we get the same insights. It's seasonal. There was a low rainfall in this period. There seems to be an abnormality here, possibly a flash flood that would have come in this period, which gave a lot of water. But when the earth couldn't absorb that, the water just went away and it flowed back to the sea instead of being held in the reservoir system. And then another anomaly that we see here is during the September or November period, the availability just kept rising instead of, if you look at the past data. So this total gives you the same sort of insights, but at a city level rather than at a reservoir level. So that's just good to know. And what we are trying to do is also practice how we can create multiple new columns without having to write the code again and again, and practicing more on the Plotly library to create this chart in a fashion like this. So if you practice enough with this format of exploring data and plotting, this becomes a second nature to you. And so the questions that would come in the following code becomes much more easy to solve and tackle. Right. So let's continue our discussion. Quickly correct this. This is missing the tick marks or the bullet points. Okay, Rashkesh has an interesting suggestion. He's saying, could these be due to the cyclones? Yep. And so when I say flash flood, it includes the abnormal or a strange weather where a huge number of rain clouds came into the city because of some activity in the Arabian Sea, Bay of Bengal. And that could be due to the cyclone, that could be some other factors that are causing it. It could be a land thunderstorm that brought the winds, because you would see during this time period, January, December, it's mostly the returning monsoon that brings rain to the city. And so this brings us to the nice point where we can now investigate the rainfall and see if it has any bearing on the season. Right now, we were just looking at the availability. Now let's see if we can get more information or more insight by looking at the water levels, the rainfall levels. So there's an assumption that the reservoirs depend on rain for replenishment. And why is that? Because it coincides with the months, the returning monsoon months. So let's load that data. And so I already have the file name in my history like this. I can just simply load this. I can say rain df is pd.read csv. And if I run that, check. Again, it's got a date, so it's a good thing to load this as date. So instead of me scrolling up, I'll quickly ask you, how can I convert this string into the date? What function should I use? What parameters should I do? Okay, can anybody type the entire code? So we've got parse date, parse as suggestions. Or we could use toDateTime. So let's say I want to use the parse date. How should I use it? So in here, if I look for options, there is an option parse date. Parse dates. So Shalini is suggesting Manish should have to use parse dates and provide information here. I think Shalini, you're combining the two. The toDateTime function requires you to provide it like that. So you got to provide the column and the type, the style, the format. But if you're using the parse date functionality, all you need to do is say which column. However, let's see if it has other options as well. So if I say you can provide an example as well. So it can have mixed parsing as well. Okay, but I usually try to provide the list, the names, the columns, and so it directly works. And then we say day first, true. Okay, so day first, day, month, year. I run that, and if I check, that works. Okay, or if you want to use the toDate type, you can use it like this. So you can skip here and then use it like that. Okay, let's go down and again, quick check, see if it has any missing values. Nope, this is also nice and clean data set. So at the moment, I have daily rainfall information. And because I have daily, and I've been asked to do a plotly, a yearly, before we jump and go to yearly, let's start small. Let's start with daily rainfall. Let's start with daily rainfall. Now to get the daily rainfall, I would want the same output. So this was daily water availability. I will need the daily rainfall. So I'll leave this code up here for you to think how we can get the same plot for the rainfall. What changes would you do here? So I need the daily water rainfall for maybe different reservoirs. The first thing we would need to do is convert our rain DF, the rain data frame, into a long data frame. So we have a wide data frame, and if we convert it into a long data frame, we can simply use the same code. Prasad is suggesting, Manish, our y variable would change. Instead of water level, we may have to use a rainfall level, maybe. And how do we get the rainfall level? We'd have to use the rainfall level here. So we'd have to melt that data frame the way we melted our original data frame, the reservoir water level data frame, we melt it for the rainfall. I'll just copy this code instead of me rewriting, but I would want you to do the same. I would want you to try changing this into rain DF reservoir, and instead of water level, let's call it rainfall. And that's it. I get the daily rainfall analysis. And you see how easy it is to repurpose your existing code for the new analysis that you're doing. Once you know how to create these plots, you can then repurpose them for so many different ways. What we are seeing here is the same cyclical pattern. And this has been already merged at some sort of a monthly level for us. But if we want to zoom in, let's say in 2004, to conclude where there was a drought in 2004, we can clearly see. So it's very, very low rainfall in that period in 2004. And so you can consider this as a drought if you compare it with other years, other months. So if I just look at maybe 2005 and 2006, 4, you can see it goes up to this is no rainfall at all. The max it could go to 200. I'm not sure what's could be millimeters. Usually it's measured in millimeters. Yep. Thanks, Prasad. And so we've got a high rainfall during October. So we've got the daily rainfall. We can see some analysis. We can get some idea daily rainfall. Probably if we can combine this at a monthly level and see if there's a different pattern that we see in monthly compared to a daily, because daily you'll have a lot of noise in your data, and because it's so granular, it's good to do machine learning on that. However, to do an analysis to get an overall picture, you may want to aggregate it at a monthly level. So to get the monthly rainfall, what would I need to do is I need to calculate the daily total and then group by month and get a monthly total. So how would I get the monthly rainfall information? How would I get monthly rainfall? So the approach is get daily total and then group by month and sum it. Right, so we need to do these two steps. The daily total one is simple. We've already tried that when we were calculating the total availability for the entire Chennai region. We wrote a code to do that. We could use the same code to get the daily total. So this is how we calculated that. We could use individual columns to calculate the total, or we could simply repurpose this code. If I copy this and take it down, so this is what I meant earlier. If your code is like this, you can just use it in different scenarios as well. So I need rain df. And if I show you how rain df looks like, so we've got a total rainfall every day for the entire region. Now I need to create another column called month and then group by that column and add this. So let's create another column called month. Let's call it year month. So if I need to calculate year month, I need to calculate year month, I could do something like this. I could say rain df dot date dot dt dot year. It gives me year. Then I could add rain df dot date dot dt dot month. If I do that, I get a wrong message. So what I need to do is I need to convert this into a string maybe. And this guy is string as well. So I get year and then I get month. And then if I use pd dot to date time, and in here if I provide the format, which is year month, it's going to generate dates. So that's the and one way of creating your date, the month and year from your existing date that you have. There are plenty of other ways to do the same. But this one is, again, you can repurpose it, you can reuse it, and you can extend it if you want to take out only the year, or if you want to do any other analysis on this, or you can mix and match with other strings as well. So I'll just add this into rain df. I'll call it year month. And so what we've done so far is we've added two new columns, one total in the previous code, and now a year month, which is just the month for that particular year. So instead of using it daily, now I have different months. And so after this, if I group it by the month and then create a sum, I'll directly get year, month, and total. So this is what I meant by that. So you have rain df dot group by, and you go year, month, and then use total, and then sum it. So these sums that you're seeing now are at a month level, so monthly sums. And simply if I convert it back to a data frame, I have a nice data frame, which is a monthly data frame. So what we did, we first got the total, which was the daily total. Then we created a month, year, month column. And because for every month it would repeat it again and again, we just grouped it by the month and got it. And you can simply assign this to month, the df, and use the monthly df in my further analysis. Okay, so I could simply plot using the same function that we used earlier, like this. And instead of line, let's plot a bar. Instead of date, I have year, month. So now we have monthly rainfalls. Okay, I've got a couple of questions on the chat. Prasad is wanting to know, how does the group by work? And Dhruv wants to know, how come we only extracted year and month and we still got the entire date? And Nikhil asks, Manish, can we convert this into a week-wise? Probably. Okay, pretty good questions. Let's tackle them one by one. So let's first talk about how we got the three-part date. Um, the reason why we got the three-part date is because we use the function toDateTime. So if we say toDateTime, it is going to return a date. But because every value is just the first day of the month, the reason for that is because we only provided year and month. So it assumed the day to be the first day of that month. And that is repeated for all the dates that are available in here. So if I do a quick value count, rain df dot year month dot value counts, you'd see January 31, 2005, January 31, 2007, December 31, and so on and so forth. So February is 28. So the entire month is repeated as the first day of the month because we used date time. It converted that string to a date time. And if we do not have any one of the date or the time, pandas assumes it to be the first day or the 0th hour or the 0th minute if your string does not have all the six. So your string should have year, month, day, hour, minute, seconds. If any of those are missing, it assumes them to be either the first day and the first hour, which is 0000. So that is what happened here. That's how we got all the three components. The second question is around how we use the group by. So the group by is, again, we have 31 different values for this guy. So that's why we grouped it, all the 31 values, and we extracted the total column and summed that. So it calculates the group sum for each of the dates. Each of the dates are first day of the month. So each of the month, it sums them up. So you have a row sum or group sum, which is the monthly sum of the total. So the daily is then converted into the total of month. And depending upon the size of the month, meaning depending upon how many values we have in each group, the sum will calculate over 31 or over 28 different values. Another question was around, Manish, why can't we use, why did we create a new function or a new column? Couldn't we have just used something like this and then got the output? So let's try that and see if that works. If it works, then you probably do not have to create a new column. So let's do that and see if this guy gives you the same output. Okay. Yep, pretty much get the same output. And if I use the reset index, reset index failed. Why would reset index fail? Oh, because both have the name date in them. So how do we avoid that problem? That's something we need to figure out. So if you have a multi-index series, so this is a series. So if I just look for it, this is the Pandas series. Okay. In the Pandas series, I have the index. So I just show you the index. I've got the index. And this has names in it. So the names of this index are not right. So how about we solve this problem by renaming the index? So if I can dot name is equal to, I don't know, I'm just trying, okay, here, okay, for that to work, we'd have to first assign it to some series. So let's call it monthly monthly. So that's my series. And now if I replace monthly, and then if I check monthly index, let's see what happens. So it's only one name now. Okay, and if I go reset index, would that work? No. So state already exists. Okay. Change the name, but that name didn't reflect. Okay, there should be a way. So multi-level index series to data frame. So this works if you have two series that can reset index directly. So you can go one by one. You can try unstack and see what happens. Okay, and let's try that. Okay, returned a white data frame. Nope, doesn't work. Okay. I was thinking if we go pd dot data frame, what is this return? And then I can say a simplest one would be how do I assign the names to multi-level index. And there's series rename. Oh, there was good. Okay, there is rename. So you can use set names as well. Oh, that's interesting. So set names. This guy's saying rename. Set the new names on index. Default returning the index. So you can provide level and the string. Okay. Can it be tuples? Has to be a set. The examples are not good in this one. Okay, let's try. Let's try the names like this and see if that solves our problem. So monthly dot set monthly dot index set names, and then it is month level 1, level 0, level 1. Let's see what we get. Okay, this replaces name. Cool. And if I go monthly dot index, And then if I go monthly dot preset index, awesome. So that would work. However, you still have two different columns to work, and the plotting may be a little difficult if you have two different columns. So yeah, you might again have to merge the two. So there seems to be multiple ways of doing it. As I was saying, you'd have to figure it out which one works for you. The work that I show you in the code along may not always be uh, the only way to do stuff, but that gives you a reference point. And if you have another idea, you can explore that and you might find different functions. Like for instance, I didn't know that we could replace names to the multi-level. So you search, you find some answer and you try that.
Manish.
Yep, go ahead.
Yeah, so right now we got that year and month wise data. Right now, if
Exactly.
you see that it's not a date. Okay,
Yes.
we got it as a month number wise. So
Hmm.
I don't know, might be I'm wrong also. Correct me over there. If I need that week wise, okay,
Mm-hmm.
suppose here. So we know that date frequency is that what we call weekdays. I mean Sunday, Monday, Tuesday, like that.
Yeah.
So every year's frequency is different for that. Okay, if
Yes.
we try to convert to week for the particular month, suppose
Mm-hmm.
consider 2021 January month is having 31 days. If
Sure.
it is starting from the Thursday, if I'm right, sorry, Friday. So if you count the 7 of each weeks, okay, so it will give you the 4 weeks of up to 28 date. After that, it will consecutively add that with the February 2 3 days and January 2 3 days. Can it be possible here to get it the details with that?
So to get the week, you could directly use this. We'll give you the week. So you don't have to do much of this
Okay.
manipulation based on the day, based on the month.
Mm-hmm.
Pandas has done that for you. So you can directly use this.
Okay, and the summation also will be reflected with this one, correct?
Yep. So if I just convert this and instead of month, and if I say I want, let's say weekly, right?
Okay.
So I'll just copy this and go bottom, paste, and then cut. Sorry, just give me a second. Okay, so we've got the week here. All I need to do is change the month to the week, and this I'll change it to weekly. You see how what I'm going from here,
Yes,
right?
yes, yes, yes.
And so instead of this calling it month, we call it week. And this didn't. Oh,
No, yeah,
yeah. So now we've got weekly data.
yeah, yeah. Sorry, I hijack your thing, but I
No,
had
no,
a
that's
doubts.
the same thing that I was talking about. So because there are so many different ways of slicing and getting the information, that's why it's important to straight away parse it as a date, so that if you want to do further analysis,
Mm-hmm.
monthly, daily, weekly, you have that capability. If this was a date, then you can then use it as a date column. It exposes all sorts of different things.
Thank you for
And yep, thanks Prasad for also pointing out that if we do it like this, we may be able to also increase our way of working. And so the next step for me, if I want to put this into one sort of a column, I can merge them in single string or into a single date, or just use the um, I don't know if I've never tried using two columns in x-axis and see if it works. It may work. So what I'm trying to do is if I want to use this in a weekly plot or in a monthly, so we have two x-axis now. I have year and I have week, and I have total. So if I change this, and I'm crossing my fingers here, it may work. And yeah, it didn't work. So we'd have to find how we can give two different columns as access to our plotly. And then we can probably just use two different columns. Haven't tried that. So maybe after around the end of session, we'll try to see if we can solve that problem as well. Instead of me having two different variables, this is a combined variable. Kind of create a new variable. So yeah, okay. This is like a to-do for us. Use multiple columns in axis. Or I could use the asset call just for now. And so you'd see different years. And if I go facet call wrap 4, I'm looking at 4 different years, and this is the weekly plot. I can increase the size and height and width of this plot by changing the height and width. I don't know, maybe 15. Oh, 15 is too small. Yep. So you have a weekly plot for each year. Yep, I think this is a good enough way of solving that. Okay, where were we? We were trying to create monthly, so I'll unscrew that and put it here. We got monthly, we've got weekly, and we've got daily as well. And I'm assuming that you all have the code at least to this point where you can create monthly. Okay, so you have monthly rainfall for all the different years. The one last point I wanted to try and talk about was if we could add the seasons to this, instead of just using it as a monthly data, we can color it based on different seasons. And so in India, we have majority, primarily 3 seasons, raining or monsoon, and then we've got a summer and winter. However, the way the meteorology department captures, they specify the seasons as 4 different seasons. So you have winter, summer, which is sometimes also referred as pre-monsoon, then you've got monsoon, and you've got autumn, which is also referred as post-monsoon. And you have different months associated with it. So you got December to February, winter, March to May, summer, and then June to September, monsoon, and then the returning monsoon, which is usually October to November. And this is where Chennai gets its most rainfall. So if we can color our plot based on these seasons, we would have much richer information in this plot. Right now, I see there is October, November, December. So yeah, October, November, it gets majority of the rainfall in that region. However, I have to really highlight or hover over it to just get to know that particular month. But if I could get it at a glance, then this would be much more useful insight in the plot. So to do that, before the session, I visited Stack Overflow site. How can I associate different months to different seasons? What I learned was you could create a map. And so this is what we created. I created a map. So this is month, and that's the season. And so you can see it starts with winter, summer, monsoon, post-monsoon. So just following the same pattern that is specified here. Winter is, so I made a mistake here. Winter is here. And then you've got 3 months of summer, 3 months, 4 months of monsoon. And so you've got October and November. October and November is post-monsoon. Okay, and so if I create this map, then I can assign this map using the monthly DF that I already have created. I've got this monthly DF. I can simply assign it. I can say year month dot dt dot month dot map, and then I can pass this dictionary and see what happens. It returns the labels based on the month, and then I can create a new column, call it season, and then I have data frame. So now I have seasonal information, and that's associated with the months that I used. Okay, and so if I have to then create a seasonal rainfall instead of a monthly rainfall, so how much is in monsoon, how much is in summer, I can do that. But before I do that, I can color this guy. And what I'm trying to say, I can simply use the color column, and I could say season. And something failed, probably my comma. And now it becomes much more visual. You can see Chennai receives in summer as well. So that's interesting, right? May is kind of pre-monsoon, so it does receive some pre-monsoon rains, which is interesting. And then most of the rain is happening in post-monsoon season. Sometimes it does receive rainfall in the winter as well. And like now it's much more clearer if I want to talk about Chennai receives more rainfall in the post-monsoon, and I can validate that claim by meteorological department saying, yep, a lot of the rainfall happens during post-monsoon season. And I can clearly see that. So to get to this code, we just created a map, and we assigned that map, and we created this column. Yep, that's right, Dhruv. And with addition of this interesting column, and we get in for much more information. And the use of the color is much more indicative of what we are trying to emphasize on. So combined rainfall in monsoon would be much higher, but most of the rainfall occurs in these 2 months. And this will very well coincide with the availability as well. So if we look at our previous charts, the availability you would see during the post-monsoon period, the availability goes higher and higher in the water reservoirs. So you can see it goes up, which is a good indication that if we get a good rainfall, the water is stored in these reservoirs much better. Okay, pretty good insight. I would say we'll just quickly note that Chennai receives most of its rainfall during post-monsoon season. Okay, I hope you are able to capture this, because now what we're going to do is we're going to build on it. And then we would create a yearly plot. So now we come to our actual question, which is the yearly plot. We did daily, weekly, monthly, seasonal. Now we are reaching to a yearly plot. To get to the yearly plot, we already have our monthly DF. We can use this monthly DF to get to a yearly plot. What steps would I need to take to get to a yearly plot from here? Or a yearly, what do I need to do here? Or should we start fresh and look at directly the rain DF and use some ideas from here? So you can probably calculate yearly total from the original data frame, or you can create your yearly data frame from monthly. So Arnab is suggesting, Manish, let's group by year. Prasad is suggesting the same. Let's group by year. So we can reuse or repurpose our year month column in either of these, and then group by year. What do you do after grouping by year? You sum the total, and then you get an yearly sum. Now, I'll show you what happens when we do that, and how can we add more information by using the season as well. So there will be 2 more plots coming up for the yearly one. So let's first do a simple yearly plot where we group by year month. And so I'll extract year month. I'll say a year month dt dot year. Doesn't work. So I probably have to say rain monthly year dot year. That works. So I then go total dot sum. So I get yearly sum. I use reset index. I get an yearly data frame. Okay. So I got my yearly data frame. I just go ex dot bar. I use my yearly data frame. I say my x is my year. And the column name is not replaced, but we can create a new column. And my y is the total. And my title is yearly rainfall in Chennai. So you see the yearly rainfall in Chennai. Now this loses the concept of season. And so Prasad suggested earlier we could try stacking each bar and maybe create a stacked bar graph and see if we can use the season information at a yearly level. Now, to get to that, what you need to do, you need to make some more change. So instead of using the grouping by on just the year, if you group by on year and season, if you group by year and season, then you get seasonal total per year. Okay, if I get seasonal total per year, and if I use that, seasonal total per year, and if I use color as my season, you see that. Another beautiful diagram. So you can see clearly post-monsoon, just 2 months, surpasses most years the monsoon rainfall that Chennai receives. Except some years where the post-monsoon is very, very meager, and then you may have a drought-like situation possibly. But if you still see in many years, majority is the majority of rainfall comes in only these 2 months. Okay. So this insight is still valid. Most of the rainfall is during post-monsoon. Now both gives us the same output, but this one is a blend output. It doesn't have much color to it. It just tells you, okay, these 2 years had the highest rainfall, and on an average, you're somewhere around 6,000 million cubic feet, or maybe around 4,000 or 8,000 million cubic feet. But this gives you much more color as to during post-monsoon, this is how the rainfall looks per year. And if we add the monsoon, this is how the rainfall looks, which is pretty good story to tell. And sometimes we receive it in summer as well, which is pre-monsoon, and sometimes we receive it in winter as well. All right, this last section is what we would be dealing now is the water shortage estimation. Now, if your summer has some water availability, then does that indicate you need more rainfall during monsoon and post-monsoon? So if your availability of water during summer months is very, very low in these reservoirs, then probably you are hoping or praying for a good monsoon and post-monsoon rainfall. So this is the last piece we're going to be looking at. We need to be seeing what are the water levels at the beginning of February, and if these reservoirs need any replenishment. Anthony is suggesting an interesting pattern. He's saying, Manish, there is also a decade cycle. So not only within year we have a seasonal cycle, but we have an even bigger cycle, which is a decade cycle, which is around 2005. We had 9,000 million cubic, and again 2015. So possibly in 2025 we would expect a very high cycle as well. And so this is a good observation, Anthony. And sometimes you would find the weather reporters, the meteorologists, they talk about these decade-long cycles as well, which is in the weather pattern. And you're quite right. And this is very evident because we've got such a long duration of data, we can see that pattern as well. So not only we have cycles within years, but we have much more broader longitudinal cycles as well. Okay, I'm going to take a quick water break and come back, and we'll solve the last problem. I'll leave the screen here, so if you want to generate this yearly plot by season, you can look at that. Probably, yeah, here. Okay. So let us continue our conversation and see if we can estimate a water shortage, in which months we might have to plan for it. First step that what the analysis suggests is we can take the water levels at the beginning of February. And now we're looking at the reservoir levels. So I already have my reservoir data. Okay, so that was our reservoir. We've got total every day. So I've got a daily total. All I need to do is look at the daily total at the beginning of the season. So if you want to look at the beginning of the season, you can see summer actually usually begins in March and not February. So it's probably a good time to look at the March rather than looking at the February. So if we look at the March instead of February, that would be a better assumption. So if I have to look at March, I could say df.loc, where df.date.dt.month is equal to 3. So I get only the March data, and df.dt date.dt.day is the first. So I get March 1st data for all the different years. Okay. Now all I need to do is just plot total. Sorry. There it is. But we are trying to plot it using Plotly. So this is not a good plot. To plot it using Plotly, we could say px.bar. And then I could say x is my date and y is my total. And this is the title, availability of water in total at the beginning of summer. You can clearly see why 2004 had a problem, because at the beginning of summer, almost all water was used. There was no water available in these reservoirs. So even if the rainfall did happen, it was not sufficient. And contrasted with 2020, the beginning of the summer, there was a lot of water available. So I think above average, you can see it's even above average. The average is around 5,000. 5,500 MCT. If you're like me, you want to plot the average line here. I think you can plot by using one of the parameters that are available within the library. Which I think is AX, or I think you could just say px.line. So I'm trying to add Plotly and line horizontal line. add edge line. So if I use that, if I go back in my plot, I grab this as big, and I add the line at the mean. See, that's the mean. It's above the mean. I could probably add some text to it as well. So you can add line color. Oh, this is good. You can also add some rectangles. You can say above that, there's a different one. And adding text notation. This is what I was looking at. So you can add the notation as well. And line dash is dot. So we'll use these information. We will add this in our line dash dot. Average rainfall, average water availability. And probably you can change the color as well, I guess. Yep. Line color. Okay, this looks good. And again, if you want to reuse this, you could say average water availability. So if I put this as a variable, then you can see it could be used in multiple places. I could say, why is this? And then so you could put it into the text. Use F. And then you can see the value as well. Then you can use and it rounds it up for you as well. If I don't provide a position, puts it at the top right. Okay, sounds good, looks good. Probably white. Now the text doesn't change. So annotation text color, possibly it has a another argument that we could provide. No. We need to figure that one out if we want to change the color. Okay. So again, if you haven't explored any of these features, just like I did not, but I had an idea, let's add this information in here. So this is how I usually go. I look for the proper information and try to find, there it is, animation. In fact, we can increase the size as well. That's good. Okay, so it was not annotation text, it was just annotation font. And so just try to read the documentation. You would most probably find all your queries answered there. Let's try. Okay, I think this is not a string. So this is not a string. The number. Nice. Yeah, I kind of have to play around to get rid of this blue color possibly in the bar chart, and then just find the one that matches with my background as well. So black didn't work, white, red, let's see. Red is a little bit more readable. And so you might want to change the color of your bars to does not represent anything. All right. I think this was it for today's session. If you've got any questions that you want to get answered, this is the time. And if you don't have a question right now, think of how would you solve this for a how would you solve this type of a problem using similar analysis? And if you want to tackle any of such problem, Kaggle has a lot of other data sources that you might want to use and see if you want to bring it over. Maybe it has some data sets around North India, or maybe you want to try creating a chloropath, which is like so you might want to try something like this, where you want to plot the different regions within Chennai, and using the geospatial data, you may want to try something like this at a regional level and see if it has any correlation. What I was able to find was another analysis done by someone, and using these maps, they looked at different water and flood related data at a geospatial level. This is not using Plotly, but you may want to convert this analysis into Plotly, and instead of using GIS, ArcGIS, you may want to use Plotly to plot your maps. And so you can use Plotly to plot these maps and do this analysis. It's just that you need your data to have something called GeoShape. How does that look like? Let me just quickly run you through that bit. Here it is. So it looks like this, which has the latitude and longitude information. So along with the date, the amount of waterfall, it also has like a shape, which is like a polygon. And then it also has some other information, shape length and shape area. So you can generate this type of pandas data frame. It's usually referred as a GeoPanda, another library which uses pandas in the background. Once you have a GeoPandas frame, you can pretty much create a chloropath map like this. So all you need is a GeoPandas frame, which should have like a information around the shape that you're looking for. And then there are plenty of other websites or other data sets that provide you this information. So if I just look for geospatial and Chennai maybe. I may have some data sets that have a geospatial and see if it has any relation with the flood and the restaurants possibly, and you want to see how that works out at a map level and do some analysis on that. So think of other use cases or other data sets that you can mesh and create much more richer analysis or insights. As always, before you begin doing any analysis, have those three questions in your mind. Who is my end user? How are they going to use it? And what format do I need to present my analysis to them? Should it be an interactive one? Should this be a PDF or a report? And if it is to be consumed as interactive, you can use Plotly, you can use the other libraries to create like that. Yep, through suggesting green looked better than red. Yeah. So yeah, you can play around with the different colors and see which one you like. However, I just wanted to share, you can style your code and add more richer information to it. Okay, if there are no more questions, we will call it a day, and I hope to see you in future sessions. Before I sign off, I'll show you what we could do with Kaggle. I could quickly save, and then I'll get a link, which I can share a link with you, and so you can refer my code. So what Kaggle is doing in the background is running this end-to-end to see if there are no issues. So if your notebook has errors, it will stop and it may not save correctly. But for me, it was able to correctly store it, correctly save it, and then I can just view that version. And once I have this version, you can see it's clearly converted into a HTML document. And I can share this document with anyone, and they can fork it just like any other Git repository and make more changes or make interesting analysis, create it even better. So that's the code. I'll also share it on Slack afterwards. And please fill the feedback form. And see you next time. Bye-bye. To share IPYNB, I have to see if I can save it as IPYNB. I can download the notebook. But the better way would be to just use Kaggle. So I'll give you a link and then you can just use that link. Okay, page not found error, not working. Oh, interesting. Oh, it's because it's private. Okay, let me make it public. And save. Copy. Good to know that it wasn't working earlier. Hopefully this one works. Yep, awesome. All right. Cheers, guys. Bye-bye.
Thanks, Manish, for a great session. I'm requesting everyone to please share their feedback, and we'll see you next week. Thank you.
Yeah, bye-bye.